to section 10.1, adding and subtracting polynomials. When we finish, I want you to know the terminology that we've talked about. There's a lot of vocabulary in this lesson. I also want you to be able to place the polynomials in standard form, and I want you to be able to add and subtract them. So there is quite a bit of vocabulary. So first of all, a polynomial. Polynomial is the sum or difference of two or more monomials. So when we talk about monomials, we're really going to be talking kind of about a term. So expressions that have one, two, or three terms have special names. So we're going to be talking about those special names in just a few minutes. So let's look at some of the details of polynomials. Now the degree of each term is the exponent of the variable. So this first term is a third degree. This second term is a second degree. And it's called a second degree because of this exponent, not because of its location. My negative 4x is a first degree, and 7 is a 0 degree, or a constant, because it doesn't change. Now when I talk about the degree of the polynomial, that's the largest degree of all of the terms. So I know that when I look at this polynomial, that it is a third degree polynomial. Now that's really important to me because that tells me what this graph is going to look like. All third degree polynomials have a similar graph. There's some slight variations, but for the most part they're the same. Okay, let's look at a few more details. Now standard form, that means my terms are placed in descending order from the largest exponent to the smallest exponent. So mine go 3, 2, 1, 0. Now when these are written in standard form, the leading coefficient is going to be the coefficient of the first term. But make sure that it's written in standard form. It's not just the first coefficient. It's the first coefficient when it's written in standard form. So this leading coefficient would be 2. Now earlier I was talking about the names of polynomials, and we do have some that have special names, and I expect you to know these and to be able to talk about expressions using their proper names. Now when I have a monomial, that's a number, a variable, a product of one or more, or the product of one or more variables. So 2a is a monomial. Negative 6b, x times y times z, 7, 3 divided by x. Those are all examples of monomials. Now a binomial is a polynomial that has two terms. 2x minus 7, 3x squared plus 4, x plus z. Those are all examples of binomials because these all have two terms. So this one, the terms are 2x and negative 7. Now a trinomial is a polynomial that has three terms. So in this example, a is a term, positive 2b is a term, and negative 4c is a term. Now one of the things that's kind of neat about this is we're going to be able to classify these polynomials. Now as we get more comfortable with this, we're going to be able to know a lot about the expression or the equation that we're talking about. Now when I talk about the degree of the polynomial, that's going to be the highest exponent. So the first one, it's 6. Well, what's the degree of that? What's my highest exponent? 0. I don't have a variable with an exponent. Now when I classify this by degree, does 6 change at all? Is there any way that it changes? No, so whenever I have a regular, nice, pretty number, we call it a constant. There's no variable with this at all, so it stays constant. My leading coefficient is 6. Now, how many terms do I have? I want to classify it by terms. I have 1, and I know if it has one term, it's a monomial. Okay, negative 2x. What's the degree of this polynomial? I'm looking for my highest exponent. Oh, this one has an exponent of 1. I can't see it, but it's still there. Now, when I classify this by degree, oh, this is linear. I know that all polynomials that have 1 as my highest exponent, they make a line. What's my leading coefficient? Negative 2. And I classify it by the number of terms. How many terms do I have here? 1, so it's a monomial. 3x plus 1. What's the highest degree? What's my highest exponent? 1 again. Oh, exponent of 1? I know that's linear. Oh, what's my leading coefficient? Make sure I'm in standard form, right? Oh, my leading coefficient is 3. How many terms do I have? I have 2. What do we call a 2-term? Binomial. Next, I have negative x squared plus 2x minus 5. What is the highest exponent of a variable in here? Well, it's 2. Now, this one is called a quadratic when I classify it by degree. So remember, all of these are going to have consistent graphs based on their type. Linear is going to have a similar graph. Quadratics are going to have similar graphs. So you're going to have an idea of what all of these are going to look like when they're graphed. Now, what's my leading coefficient? I'm in standard form. Oh, my leading coefficient for this one is negative 1. I have 3 terms, so it is a trinomial. Next, I have 4x cubed minus 8x. What's the degree of this polynomial? That's right, it's 3. Now, when I have 3, when I classify it by the degree, it is cubic. I'm in standard form, so my leading coefficient I know is 4. And when I classify it by the number of terms, I have 2 terms. It's a binomial. Okay, now the next one, I have negative 7x cubed plus 2x to the 4th minus 5x plus 1. What's the degree of this polynomial? Oh, be careful, it's not in standard form. The degree of this polynomial is 4. Now, when I classify it by degree, this one is called quartic. Okay, now what's my leading coefficient? Nope, it's not negative 7. Because remember, I'm classified by the leading coefficient when it's in standard form. So what's the coefficient? Okay, let's put it in standard form. I've got 2x to the 4th. That's taken care of. Minus 7x cubed minus 5x plus 1. What's my leading coefficient when I'm in standard form? It's 2. Now I've got 1, 2, 3, 4 terms. Whenever you have 4 or more terms, you're just going to call it a polynomial. Okay, now there's just a lot to remember. Don't neglect being able to recognize these. It's going to be really important. Okay, now we're going to be adding and subtracting these polynomials. The main part of this is you're going to be combining like terms. You've got two ways you can work them. You can use the vertical method where we're just going to line up the like terms, or you can use the horizontal method. I'm going to let you choose which one works best for you. Okay, find the sum or difference and write it in standard form. So the horizontal method, I'm just going to go through and I'm going to combine my like terms. So I'm going to circle these. I look in both of these. My highest exponent is a 2, so I know I'm combining two second degree polynomials. 2x squared, and addition right here, that's going to be really important to pay attention to, and a positive x squared. What does that give me? Just add your coefficients. That gives you 3x squared. My next one, a positive x combined with x plus 2x. Negative 5 plus 6. Let's just plus 1. I double check to make sure I'm in standard form, and I am. And that's my solution. The one thing that's a little bit challenging about the horizontal method is sometimes if you're not careful, you can leave out a term. And you want to make sure that you do not do that. Okay, find the sum or difference again and write in standard form. Now this time I'm going to use the vertical method. That just means I'm going to line them up. So I'm going to see if I have any x squared terms, and I do. So I'm going to put a little positive x squared over here. Do I have any x terms? Yes, I have negative 2x and then minus 7. Well, what's 6x squared plus 1x squared? Well, that gives me 7x squared. Negative x minus 2x, that gives me negative 3x. Positive 3 plus 7 gives me negative 4. Going to double check one more time to make sure it's in standard form. It is, so that's my answer. Okay, now this one, I really prefer to use the vertical method whenever I'm subtracting. This one's going to be a little bit different. You have to distribute this negative to each and every term inside these parentheses. So what is negative 1 times negative 2x cubed? Okay, well that's going to give me a positive 2x cubed. So when I rewrite it, I'm going to line it up under the terms. Let's see, do I have anything that's squared? No. Okay, a negative 1 times positive 3x, it's going to give me a negative 3x. Now notice what I did right here. I skipped a space. I don't have a term that has x squared, and that's okay. I'm lining it up with their other like terms. Sometimes you're just going to need to make a space for that, and that's okay. Negative 1 times negative 4 is going to give me plus 4. I'm going to go through and combine these. Negative 2x cubed plus 2x cubed. Oh, that adds up to 0. I'm going to bring down my 5x squared. Negative x minus 3x, that gives me negative 4x. 8 combined with a positive 4 gives me a positive 12. I'm going to double check one more time that everybody's lined up just right. They are. And that's my solution, or that's my simplified form. Okay, now what do I do if I'm adding 3 of these guys? Well, I'm going to do the exact same thing that I do when I'm just combining 2. So I want you to take a minute, combine your like terms, make sure everybody's in standard form, and I'll post the answer in just a second. So go ahead and hit pause. Okay, so when I combine all of these, my simplified form is 4x cubed plus 5x squared minus 4x plus 6. I also want to make sure that you can list the degree, classify it by degree, the number of polynomials, those kinds of things as well. And that's it.